There's no doubt at all that we're entering an industrial revolution. It's clear to everyone. AI is leaving the niche and is moving to the mainstream. The opportunities for creativity and productivity are clearly significant. It's internet level important, that's well established now. But adoption at scale, and we heard some of this with Daniela before, is not easy. What 25 years ago was simply a technical problem, can I build a technical model, is now a much broader and more holistic topic. It's a question of sovereignty, of IP, of cybersecurity, of resilience, workforce relations. It's a much more complicated topic than it was, and that's before we even start talking about the unreliability of the technology, something that we often mask with new words like hallucinations. These are errors, faults, and waste. The path to value, particularly for engineering organizations, is not straightforward. Lots of progress has been made, particularly with simple productivity and conversational assistance. And these things are things that we all just have to implement. This is money that's being left on the table if you're not already on that journey. But today, I'm really excited to be talking about a more deeper and more complex topic, which is how we bring this technology to the more exacting world of scientific discovery. So I'm very pleased to be joined on stage here by Dr. Alan Griffiths, who's BAT's Global Head of Science Discovery, Dr. Mark Roberts, who's Capgemini's CTO for Applied Science, and the co-lead of Capgemini's Group AI Lab. So Alan, perhaps you can start by talking to us about the importance of science to British American Tobacco.
No, great. Thanks, Andy, for the welcome and the intro. I think one thing it's important just to establish a little bit of context. So our ambition is to have 50 million consumers of our smokeless products by 2030, and then to accelerate the growth of our smokeless revenues to 50% of our revenue by 2035. And science, will play a huge role in our efforts, and that's going to be supported by external engagement with regulators and other key stakeholders. But in order to lead in science, we've also got to establish those intuitive data management systems and infrastructure. We need to evolve the culture with scientists openly embracing that hybrid way of working, so adopting digital and physical tools in harmony. So again, working with partners such as Capgemini, that's essential for us to build that digital ecosystem, to help us develop those new tools, develop those agile ways of working through, proof of concept sort of evaluations before we then, scale any of those developments. I think it's also important to highlight that, the transformation has to be business-led, and then the digital technology is the sort of key enabler.
Mark, Alan describes this in quite a rounded way, with science at the heart of the organization, and has talked about some of the broader topics around data and governance. How common is this type of analysis? How much more widely do you see this in industry?
Yeah, I think it's actually really, really common. One of the things we see at the moment is that science and technology are converging. And by that I mean, to make progress in either, you need to be good at both. So we see science companies needing to embrace technology. We see the traditional technology companies branching out into what would normally be called scientific domain. And they're not doing that just for fun, they're doing that because they recognize that to make progress in either, you really need to thrive in both. And the line between science and technology and data science and AI is not just blurred, it's gone away completely. And the only way to make progress is to have all of that expertise in one place, all focusing in the same direction. But if you can do that, it unlocks a massive amount of potential, a completely new way of working. Some people say, and I don't disagree, that it's almost like another industrial revolution.
Well, I used that language at the beginning, and the way you describe it, that blurring of boundaries, bringing things together, it certainly does sound like we're changing things quite fundamentally. I mean, Alan, what has been BAT's approach to embracing this, let's call it an industrial revolution?
Well, again, I think facilitated through our interaction with Capgemini, we've taken a bit of an outside-in approach and really evaluated, understood how other organizations have adopted sort of digital ways of working. And again, I think we've sort of probably honed in on kind of three key areas. So One of those is having absolutely a clear vision and then communication in terms of what our strategy is around digital. Fully empowering our teams to really embrace a digital approach. So that's across product and science. So we're really sort of encouraging that integration then of data across the organization. I think then it's about developing our people to really understand the art of the possible. So with that data and knowledge and expertise, how can you then start to elevate the organization in terms of driving that, those digital tools? And then I think that the third element then is, how do you then start to utilize those digital tools at an earlier stage of both the science and the innovation pipeline? So I think the earlier you can get in there, developing maybe some predictive capabilities, you can really then start to sort of streamline some of the processes around science and innovation.
Very interesting. It's quite interesting, you're using the language of transformation, matching with the scale as well. Mark, how is Capgemini responding to this shift?
So, we've recognized this a long time ago, and in fact, we've been working with AI not just for the last few years, but for the last few decades. So, I guess we're already more mature and balanced in our outlook. Internally, we've adopted a program within our engineering division that we call augmented engineering. This idea that, this recognition that AI by itself is not enough to solve problems to the degree of accuracy and reliability and trustworthiness that are required for science and engineering customers. And I think it's one of my favorite quotes that I use a lot in my talks is that you won't be replaced by AI, but you might be replaced by someone using AI. And we often use that to talk about individuals, but it applies just as much to organizations as a whole. Organizations that don't embrace AI may well be replaced by those that really are embracing and making the most of AI. So we've been adopting this approach. We've been pushing this augmented engineering philosophy for a couple of years now and really accelerating the expertise that we've had over decades of science and AI into something that's a whole new discipline, effectively.
And perhaps you can, Mark, drop down into a bit more detail. Can you say a little bit more about the types of things that you're implementing inside the business?
Yeah, so I think, okay, so I deliberately used the word discipline in the previous section there. This is not just a technology that we need to adopt. This is a whole new way of thinking. It's a philosophy. Our French colleagues call it a métier. It's a vocation. It's a calling. And I think we're looking increasingly, how do we train the next generation of engineers and scientists to be at one with this technology, not just a tool in their toolbox, but something that's integral to their being. So, for example, we have a whole raft of training and upskilling throughout Capgemini, right the way from general awareness for everybody through to deep technological training for our solutioners and architects. We have increasingly been pushing towards developing assets and accelerators, using the expertise that we have to create tools and platforms and things that we can take to some of our customers to accelerate their journey along this path. AI is moving so quickly that you can't afford to just sit and wait for a customer to ask for something. You need to be proactive, you need to look over the horizon of what's coming next and start building things in advance of that wave. And then the last point to make on this is that I talk about anticipating the next wave. The truth is that there are at least two big waves hitting us. There's a short-term wave, which is really about using AI technologies to do the things that we already do, but quicker and better and faster. There's just that simple productivity that you mentioned earlier. Coming over the horizon, though, there's a massive tsunami, which is where we transform what we do through AI. Not just do what we already do, but better, but do new things, create new markets, create new products, embed AI within products in a different way than we have before.
Really interesting. And Alan, perhaps you can drop down a level of detail, perhaps, and tell us a little bit more about how you're progressing specifically in this area around the science part.
Yeah, so I think it's important, in terms of the first phase, it was all about us developing the foundations. So I think it's really important to have those sound data foundations. I think it's very easy for organizations to probably jump into the world of AI, but you've got to have those data foundations in place. So I think one of the things that we did was, and we've got good examples now of being more data enabled. So we know where our data is, and I think that's really important so you can reuse your data. And again, then you move on to the next phase in terms of being data driven. And again, what we're now seeing is this evolution of us being more data driven. For example, we've got some lovely examples now of being more predictive, for instance, with being able to predict shelf life of our products. So again, I think those elements are really important. And then as you build that confidence, you then start to move into the world of AI. And again, that's where we've worked with Capgemini on the co-scientist. And those opportunities now to really leverage AI in terms of evaluating vast arrays of scientific publications through the co-scientist have been absolutely transformational. And now looking for opportunities to extend that technology further into other areas, again, is very exciting for us.
Okay. So Mark, Alan's used the phrase co-scientist. Can you maybe explain a bit more about what we mean by co-scientist?
Yeah, so the co-scientist is a concept we came up with probably about 18 months ago now. And again, it follows on naturally from the augmented engineering philosophy that I was talking about before. We recognize and we heard directly from our customers that the generative AI in its sort of normal default form is just not enough. It's just not good enough to work in the science and engineering domains where being correct really matters, where being explainable, being transparent, being aligned with known science, for example, and known scientific principles. So the co-scientist was born from that idea that we need to create AI which understands science, which can understand basic scientific concepts, can do reasoning about scientific concepts, and in doing so be more useful for a scientist in assisting them, rather than them having to always work out whether an LLM is hallucinating or not. Let's combine that LLM with systems that are grounded in the reality of logical inference about structured knowledge. So we often talk a lot about hybrid AI, which is this idea that we mix together this sort of big statistical models like LLMs with what you might call more old-fashioned types of AI that do symbolic reasoning about structured knowledge, that use logical inference, where we can use some of the big knowledge graphs and structures that we have that we've developed over previous decades and exploit that structured knowledge rather than just having this more artistic interpretation that an LLM might give you.
And in terms of the types of co-scientists, do you think there's only one type, or do you think there's different levels of maturity here?
No, it's definitely different levels of maturity, and I think by definition this is a concept that scales. So the way it's developed is as a multi-agent system where different agents specialize in different types of scientific reasoning, different types of activity, for example, searching the scientific literature or analyzing patents. So it inherently scales like that as you add more capabilities in. And actually, we call it a co-scientist, but we could equally call it a co-engineer, because the principles there, that grounding in the fundamental scientific, mathematical engineering reasoning, are what really brings it to life.
And you mentioned agentic, it's the topic of the day. Is this something that co-scientists will be moving into, or something that's already there?
It's already there. I mean, I think it's a natural way to try and build this sort of system, rather than trying to have one type of AI that does everything, which is probably impossible and would be too generic to be useful. We go the other way, and we have depth. We have agents that really understand topics in a lot of detail, and general agents above that can orchestrate those specialists to achieve a particular goal. It is absolutely how we're going to be building most systems in the future. I think the reason that agentic AI is so important is not because of the technology, not because of agents. It's because it moves us to an era where we can start describing our problems rather than having to describe the solution. For all of computing history, when we want to get something done, we have to specify the solution in immense detail. The promise of agentic and autonomous AI is that we can state our problem at a high level, and behind the scenes that will be broken down and solved, but we no longer need to think too hard about it.
So, Alan, listening to both of you, it really feels like there's a meeting of minds. Can you say how this working together has really inspired the work that you do?
Well, again, I think just going back, I think in terms of applying AI, there's massive opportunities for us to sort of be more efficient in terms of the way that we're delivering outcomes. So again, I think in terms of the co-scientists, that opportunity to accelerate the assessment of vast numbers of scientific literature. But I think then you've mentioned the word agentic, that opportunity then to connect with multiple agents and then to really drive those insights, whether that's fundamental science, whether it's technology trends, whether it's the white spaces. I think there's some really exciting opportunities there for us.
Very good. And Mark, just stepping back out from the detail, how do you think this collaboration is going to help inform future work that you do? What other developments do you see happening in this space?
Okay. I mean, I think collaborations like these allow us to really push the boundaries, right? The stuff we're doing is not easy, and you really need to challenge it. You need to try and solve big problems in science to realize how hard they are and how you need to evolve the architectures necessary to do this. I think these sorts of collaborations are invaluable to us, actually partnering with people who are themselves at the cutting edge of science so that we can push the boundaries of the technology to support them. I mean, I genuinely think in the future that this sort of co-scientist will be the one sort of unifying tool that brings together the sort of disparate tool set that exists currently in R&D. I mean, science by its very nature is a set of many complex independent processes that all need to come together in order to make the next leap forward. And that naturally suits this sort of architecture that we're putting together now. This multi-agent system, specialists orchestrated into one system to unify everything else. And I kind of think in the future that the co-scientist will be the first thing that scientists switch on in the morning and the last thing they switch off at night. It will be the one thing that they use. And probably to take it one step further, I think in a fully agentic and autonomous world, that co-scientist will be proactively suggesting things to the scientist rather than just being a passive and reactive assistant.
Let's close. Alan, let me give you the last word. We've talked about some of the exciting things that are being done. Where do you think this is going to get to? What's your big ambition in this space?
Well, look, I think from a business perspective, we're committed to delivering long-term value and aim to be a predominantly smokeless business by 2035. Science will continue to be a primary driver in those efforts. I think AI offers significant opportunities in terms of faster discovery of relevant research. Again, I think there's opportunities for cost savings, so freeing up time. I think that opportunity to work in that hybrid way, digital first coupled with physical. And again, I think it's just really going to help us enhance some of our decision making. So I think there's huge opportunities for us in terms of our science program going forward.
Great. Thank you both very much.
Thank you.